Hello to all of you, are watching this video. In this lesson, we continue constraining tools. We work with constraining tool with Dialog Box. We also do an exercise together. Okay, let's go on the screen and start the lesson.
I got this magic in my fingertips, designing dreams with every click. Shapes and wonders coming to life. With CATIA I cut through strife. In my mind the future's clear. No more doubts, no more fear. Crafting visions in 3D. CATIA's the key, don't you see? I can reach the sky so high. Build my dreams, no need to try. With every tool I sculpt my fate. CATIA helps me innovate. Every line precise and true. Colors bright and brand new. Transforming steel into art. CATIA plays the perfect.
Hello everyone. Today we continue discussing the constraining toolbar. In the previous session, you learned what the different colors mean. Besides that, you learned that numerical dimensions on a geometry have two states. Dimensions related to the shape of the object. Dimensions related to the position of the geometric object on the drawing page. Now you should know that constraints are two types: numerical constraints or geometrical constraints. For complete and correct constraining, we need to use both of these constraints. Suppose we have a rectangle on the page. First, we want to specify its length and width. Click on the Constraint tool to activate it. Then click on the side we want to dimension. The dimension appears. Move the mouse to place the dimension in a suitable position. Click on the page. The dimension is registered, but this is the element's current dimension. In many cases, we want a different dimension. To change it, double-click on the dimension number. The constraint definition window opens. The current dimension number is written in the box in front of value. This number is blue. Without doing anything, just type your desired number on the keyboard. For example, I enter the number 50. Click on OK. The dimension is registered and active. You can change this dimension whenever you want. Just double-click on the number 50 again. The constraint definition window opens again. Type another number, for example 40 instead of 50. When I click on OK, look at the side of the rectangle. The length of the rectangle became shorter. Click on the Constraint tool again. Click on the width of the rectangle. Move the mouse and click in a suitable location. Note that before clicking, by moving the mouse, the dimension and its number's position change. Note, after registering the dimension number, its location and the dimension lines are still changeable. To move the dimension number, bring the mouse pointer over it. When the pointer is over the number, it turns into a hand pointing somewhere. When you see the hand, click and hold the left mouse button. By moving the mouse, the number will move. If you want to move the dimension lines, bring the mouse pointer over one of the arrows at both ends of the dimension line. The same previous state is seen. Click and hold the left mouse button. By moving the mouse, the dimension line changes its position. Look at the letters H and V on the sides of the rectangle. They are geometrical constraints. Now we bring the mouse pointer over one of the horizontal sides. When the pointer turns into a hand, we click and hold. We move the mouse. It is seen that the rectangle moves on the page. It is seen that the rectangle's side dimensions are fixed. If we specify the position of one of its sides relative to the page's coordinate axis, the rectangle's color turns green. In this state, the rectangle is not movable at all either. Now we want to draw a circle such that its center is collinear with the top horizontal side of this rectangle. First, I draw the circle. I hold the Ctrl key and select the center of the circle and the horizontal line. I click on the constraint defined in Dialog Box tool. The constraint definition window opens. In this window, there are 19 different geometrical constraints. The software, based on our previous selection, enables appropriate and possible geometric constraints. Other geometrical constraints are disabled. It is observed that in this case, we have 6 different states. 2 states, length and horizontal, are checked. These 2 states relate to the side of the rectangle. Since its size and horizontality are already defined, 4 other states remain. We select the coincidence constraint. Click on this constraint to check it. Click on OK. It is seen that the circle moved on the page and its center became collinear with the top horizontal side of the rectangle. This collinearity is shown with a green O symbol. Now again, by holding the Ctrl key, we select the center of the circle and the vertical side of the rectangle. Note, here, as the rectangle is fully constrained and does not move, it does not matter which one we select first. But if we select 2 unconstrained shapes, the second shape moves towards the first shape. We click on the constraining tool with Dialog Box. This time we select the distance constraint. Instead of placing a geometrical constraint symbol, the distance dimension is specified. We can change this dimension by double-clicking. After the change, it is seen that the circle moved again. The way the circle moved was such that the collinearity constraint was applied to it. Again, select the center of the circle and the horizontal side of the rectangle. Then we activate the geometrical constraining tool. We click on the midpoint constraint. It is seen that two dimensions turn purple. The circle and the horizontal side turned red. And three dimensions turned dark brown. Note that the rectangle side was 40 millimeters and the distance of the circle center from the vertical side was 35 millimeters. So it was not possible for the circle center to be in the middle of the horizontal side. If I delete the 45 millimeters distance, this possibility is provided and the circle center is placed in the middle of the horizontal side. Note that the objects we draw are generally composed of several different geometrical bodies. Therefore, both numerical and geometrical constraints should usually be used. Suppose we have such a shape. We want the lines that are yellow to be vertical, the green lines to be horizontal, the two pink circles and arc to be concentric, the light blue circle to be tangent to its two adjacent lines. The pink arc should be tangent to one of its adjacent sides. The light brown circle center should be equidistant from its two adjacent sides. By holding the Ctrl key, we select all yellow lines. We click on the geometrical constraining tool to open its table. We click on the vertical constraint. It is observed that a green V was placed next to all yellow lines. The state of the yellow lines changed to vertical. We go to one of these lines. After the mouse pointer changes to a hand, we click and hold on the line. I try to move the mouse in different directions. It is observed that the vertical line can only move horizontally and vertically. But in any case, it maintains its vertical orientation. Now I select the pink arc and one of its adjacent lines by holding the Ctrl key. We click on the constraining tool. We select the tangency command. We click on OK. It is seen that the line became tangent to the arc at the connection point. A green equal sign also appeared. This sign tells us that the line and the arc are tangent at their connection point. Remember, to select two elements together, you must first hold the Ctrl key on the keyboard. Now we select the pink circle and arc from the perimeter. We activate the constraining command. We select concentricity command. We click on OK. The circle and arc become concentric. The software shows the concentric state with two circles where the inner circle is solid. Now by holding the Ctrl key, we select the green lines. We activate the constraining command. We select the horizontal state. We click on OK. It is seen that all green lines have become horizontal. A green letter H is displayed on them. Now by holding the Ctrl key, first we select the two adjacent lines of the pink circle and then its center. Remember, here the selection order should be like this. First the two sides and then the center of the circle. We activate the constraining command. Select the equidistant point state. The software shows this equality with the spatial symbol. Click on OK. It is seen that the distance of the circle center from its two adjacent lines became equal. Pay attention to the circle's location. Note that I can move the circle, but the distance of its center from the two lines always remains the same. Note that geometrical constraints can affect one element or several elements. Constraints like horizontal, vertical, length, fix, angle, radius, diameter are of this type. With today's lesson is finished here. Watch the lesson twice. Practice with me in the second time. Good luck. Goodbye until the next lesson.
Let's build the future.